Hey everybody, this is Jacob Linger here at REMI.
And I'm Mike, and we are both economic associates.
Yep, we are going to be presenting the part two of our PI Plus training webinars that we've been having. First things first, if any of you are having any issues with hearing us at the moment, or any issue with seeing the screen, there will be a questions feature on the right side. If you just post a question in there saying that you're having any issues, we can then help out and make sure that we can have it so everybody views this. Besides that, just some general logistical type of stuff. This will last roughly 45 minutes or so, and then we usually open it up for questions. So in total, around an hour. In terms of questions throughout the webinar, please feel free to type in anything you'd like, any questions you might have that relate to this webinar or just that might relate to any projects you're working on. The recording will be on our website as well. We will send out an email to all participants in this webinar with recording and slides from this so that you can see them later on. We usually have that in about 3 business days or so. So if you look out for that, we will have that posted. So without further ado then, we'll begin. With this webinar, if you had seen the part 1 with our co-associates, Cam and Harry, they were going over the newest version of REMI PI Plus 2.3 edition. They were going over some of the features involved with that. It was sort of a more specific webinar in going over those features. With this part 2, we're going over a more broad scope of how PI Plus can be used, how the model works. So to go over the agenda here, I'll go through an overview of the model. I'll talk about how our forecast is made, how we have our national and regional control and where the data comes from. I'll then move on to common features and questions. So these will be somewhat specific. I will say we do have another webinar that came out a year or so back, which we have a recording online of. That goes over a very sort of broad overview of PI Plus. With this, we'll do a bit of that, but since that's already out there, I wanted to address kind of a little bit more specific of features that we oftentimes have clients that ask about or that sort of help with a lot of different types of analyses. And so I'm going to highlight some of those in this webinar. And then we're going to finish off with Mike presenting a model demonstration. For the purposes of this, we're going to do a minimum wage scenario. That's just one of the many scenarios that PI Plus has been used for. Besides that, it's also oftentimes used for economic development types of projects, looking at incentives, looking over sort of fiscal analysis of different projects, a wide array of different types of what-if policy scenarios. So an overview of REMI. REMI's been around for 39 years. We are sort of the top of the line economic modeling software that a variety of different organizations use to look at what-if questions regarding policies. And so what it is it's an economic software where you can input policy changes. Those then affect your sort of regional economy in the model, and that then leads to a lot of economic and demographic outcomes that you might care about, things like jobs, output, different sort of demographic information about population change, and income distributional change. And so how this works is that we have these four features that we have on the screen. These are kind of the baseline of how the model works. So we start out with input-output. It's a matrix that takes account of inter-industry relationships. So for instance, it takes account of if you have a manufacturing plant in your regional economy, that manufacturing plant might take in inputs of some amount of labor, some amount of capital. It might buy equipment from local manufacturers or from sort of external areas. And this takes account of all that information. So to show this in a little bit more detail, I'm actually going to pull up the model itself. This is PI Plus. It's our newest version, 2.3. If I go to model details, this is where we can see some of the sort of nitty-gritty development that goes into PI Plus in terms of things like policy variable translators, economic parameters. I'm going to look at the national IO matrix. So input output, we have the IO matrix here. So if I go over, what we have is on the top row, we have all of our different industry categories, their final uses. So what this means is we can look at a specific industry. So let's say we look at government consumption, and we can think of this as kind of your standard GDP equation where we have government purchases, private investment, we have sort of final consumer purchases. This takes account of all those components, and then we can look at what goes into making those. So for instance, if we look at federal defense purchases, I will pull up here. So in terms of intermediate inputs, which are on the left side, we have about 0.79, so about 79% of each dollar spent on federal defense purchases comes from federal military output, which is what you kind of naturally expect. As well, you have then the next biggest thing is motor vehicles, bodies, and trailers. That's another main component when we look at federal defense purchases. If we look at, say, final consumer goods, and maybe we have motor vehicle parts and accessories, we can look at that. I scroll up here. So retail trade, this takes account of a large part of that. We have motor vehicle bodies and trailers. Parts manufacturing takes up a large portion of that. And so we have all of that information from in terms of one industry's output leads to another industry's input, essentially. As well as that, we can go further down. We can see the distribution in terms of labor and capital. So we have some amount of labor and some amount of capital that goes into each of these final goods. So that is an overview of that input-output table that we're talking about. I'll pull this back up. Now, next off, we have general equilibrium. This basically has to do with the long-run stability. If we look at, say, imagine you have economic development take place in your area. Maybe there is a large manufacturing plant opens. What will happen is that we'll see an increase in employment opportunity in the area, so you'll start to see people move into the area. But what will happen is that as people move in, you might see housing prices increase, you might see consumer prices increase, and as those price increases take effect, then the desire for more people to move in will start to diminish. Okay, there won't be as much of a return to moving into that area as those prices adjust. And that's what we mean when we talk about the general equilibrium effects in the model. As well, then, a third component that we use in this model is econometric estimation. So I can pull up this specifically. This deals with, we actually have a team of in-house economists, and they estimate different parameters. So I can pull up the parameters here. If we think about sort of maybe consumers' responses to price changes, they can estimate this by calculating elasticities, for instance. So if I pull up market share, this brings up the price elasticity of demand for each industry that we have here. And this is just an example of sort of the parameters that we estimate. These are then used in the equations that interconnect the model. From there, then, lastly, one of the newest components that is in the model is economic geography. This takes account of the idea of agglomeration. So the classic example of that is if we think of Detroit, let's say mid-20th century when we had auto manufacturing going on largely there. A lot of the intermediate inputs were widely accessible. You would have a lot of manufacturers that would ship to the area. And so for a lot of those automobile manufacturers, they could get these intermediate inputs for sort of cheaper prices. They could be more productive in their producing of those. You could also think of Silicon Valley as a good example. If you think of sort of productivity in technology, you have a lot of different it's a wide array of computer engineers and computer scientists in the area. So there's a lot of widespread information and a lot of productivity increases from these people being nearby each other. And so with these four components, we end up with the PI plus model. Here is a sort of overview of how the model works. I won't go into too much detail, but I will describe these blocks here. First off, on the top, we have output and demand in the first block. This is your kind of standard GDP components. So you can think of consumption, state and local government spending, investment, imports, exports. This all goes into the first block that we have. This then connects with the second block that deals with businesses, how they make decisions in terms of how many workers to hire, how much capital that they're going to invest in terms of things like machinery and equipment. And then this interconnects with the third block. This looks more at household decisions in terms of where to locate, where to migrate to, in terms of thinking about whether to participate in the labor force. And then all of these blocks then connect with the fourth block. This is where we look at prices, things like housing prices, consumer prices, the cost of production. And these prices will adjust within the model in order to bring the model into general equilibrium. And then the fifth block, we take account of domestic and international market shares. So this is where we look at the competitiveness of a region compared to the rest of the nation or the rest of the world. And so all of these blocks are interconnected by over thousands of equations in here, which we have a wide variety of model documentation, which will go over the equations in depth. I won't look at any of them specifically on this webinar. But with that being said then, it's a very sort of comprehensive view of how the regional economy works. So then this brings me to the forecasts in PI+. So how it works is that we have a national forecast, which will make it easier just to pull this up. Sorry about all of the back and forth with the screens. I just think with a lot of this, it's a lot easier just to see the model itself and to understand how it works. So I can go to view forecast here. We start out with a standard national control. So this is basically a national forecast that we have. It goes all the way up to 2060. So we have things like total employment at the national level. We have GDP. So for instance, in 2018, we had about 18 trillion in GDP. And then this goes, as mentioned, all the way to 2060. In terms of the data that feed into this, for the national forecast, primarily we have data from the BLS Employment Outlook report. This is where we get data on our input-output matrix. Things like final demand and value-added data come from that. And basically we have coefficients estimated up to 2026. From then on, we estimate labor force using BLS projected labor force rates. These deal with things like death rates, international migration rates. And from that, then, we can build the model all the way to 2060 in terms of the national forecast. With that being said, obviously, a forecast up to 2060 by any sort of model is going to have a large sort of margin of error just because of the sort of randomness that can happen in the future. So we do our best to model it as best as we can. But with that being said, obviously, forecasting to 2060 cannot be some sort of a perfect estimate. From this national forecast, then, we integrate the RSQE forecast. That is the Research Seminar in Quantitative Economics. Comes out of Michigan. We use that with the national forecast to basically integrate it with the current business cycle. So that combines with that primary BLS data to create this national forecast that we have. On top of the national control, we have our regional control. So what we do is we collect data. We have data from the county level, and then from there we build a region. This region could be, say, one individual county, or it could be bigger. We could aggregate regions to make, say, a state as a control. If we have the data available, we can make a city control. If I pull up the regional control here, this is a demo model we're using. So basically what we have are urban counties, suburban counties, and rural counties. And this is not actually a specific place, since this is a demo model. This is sort of an aggregation of a variety of different counties from across the U.S. But basically with this, we take into account demographic changes in the region when building the forecast. So we look at historical trends. Those come from the BEA, census, from the local area personal income, and a large part of it is a demographic component. So basically we have different demographic cohorts. So we have 4 race categories, we have 2 gender categories, and then we have 101 age categories. And we basically estimate each one of these cohorts. So for instance, a specific race, gender, and age, we forecast the growth rate in that demographic component for each cohort that we have. So it's about 800 or so cohorts in total based on that. And I will mention, if you want to learn some more information on this, I would highly recommend watching. We had a webinar about 2 weeks back with Scott Nystrom. He was going over this demographic forecast that we have built into the model, and he did a really good job of explaining a lot of the components there. So I would highly recommend watching that if you have the time. So with that being said, then I will also bring up here the controls. So those are our built-in controls at the regional and national level, but I will say you can also edit the control if for instance, you want to integrate your own data that you have, or if you want to run a scenario, say, a lot of people have been interested in looking at the possibility of a national recession. Something like that could be inputted into the national control by taking GDP, for instance, and having GDP decline at the national level. Or you can edit the regional control. So you can do an employment update where you sort of bring in your own employment numbers that you might have for that region. As mentioned, though, you can just sort of we will have a built-in forecast based on our data that we have for any specific region in the U.S. Let me see if I can. Oh, not responding. Let me head back to the PowerPoint anyways. So with that being said, then, what I want to bring up now these are common questions and features that oftentimes these are brought up when we're looking at work with our clients or when we're doing our own types of studies. These are just a few common features that seem to come up a lot. So I just wanted to bring these up in case. Once again, though, this is a bit on the specific side. If you're looking for more of an overview, feel free to ask any questions you might have, and we'll be happy to help. So one of these main features that comes up a lot is what's known as regional purchase coefficients. And the way to think about this is it's how much of any dollar that is spent in an industry, how much of that stays local. So, if you're buying, say, a product that's from Walmart, and maybe Walmart had that imported in, and then maybe a lot of that, the intermediates for that are not things like local inputs, then that might have a lower regional purchase coefficient, for instance. If I pull this up with PI+, actually, let me close this. Sorry, with this computer, it's a bit, can sometimes be a bit slow with this. So let me pull up the regional forecast. And the reason why this is oftentimes brought up is if we're looking at, say, a new economic development project in an area, or if we're looking at, say, a change in tax policy, for instance, that might affect a specific group of people, you can look at then how the industry output changes for specific industries. That might have effects in terms of the intermediate goods that they buy in the area. So if I pull up this regional purchase coefficient table, we can take a look and we can basically see for each industry, so construction, for instance, 0.996. So almost all of every dollar that's spent on construction in this region, at least that we're looking at, stays within sort of the local economy. Whereas something like, let's see, primary metal manufacturing, only about 28% or so of each dollar stays local. And that, once again, it has to do with the intermediate inputs as well as how much labor that industry might use. So along with that, another common type of statistic that people look at is labor productivity. In terms of the calculation itself, this is basically how much of a factor, in this case labor, goes into output. So it's basically output divided by employment for each industry. And this can be important to look at. It can be a relevant thing to take account of because basically with it, you can see sort of how labor intensive an industry is. So if you, for instance, had an increase in output in an industry that tends to have very low labor productivity, then you might see a lot of workers hired in order to produce that output. And so you would see a larger increase in employment for an industry that might have, say, lower labor productivity. I can pull up this as well in here. Bring up the standard regional control again. I can look up labor productivity. And from there, then, we can see that specific measure for each of our industry categories. One more, this is an interesting feature that I want to mention because oftentimes when we have these seminars, there's oftentimes questions brought up about, yes, we can look at sort of economic and labor market outcomes in terms of why people might move, but how do we take account of things like the quality of life in an area? If, say, there's more parks in an area, or maybe it's sunnier, maybe it's like a hotter area, somewhere like Florida versus somewhere like Maine that might be cooler. How do we take account of those differences in a region that might affect people's decision to move there, besides just being economic outcomes? And so I want to bring this up because it is a question that's brought up often. We do have something in the model. It's called amenity value. If you come from economics, this is oftentimes seen as a compensating differential, would be the sort of technical term. Basically, it takes account of all of the factors. After we take account of all the factors on why someone might move, things that come from, say, from the labor market in terms of wages, in terms of all the factors that might explain why someone moves there. This is sort of the leftover feature in terms of quality of life aspects that might lead someone to move to that area. So with all that being said, then, we are going to bring this over to Mike. He's going to do a model demonstration. Once again, we're going to do a minimum wage scenario for this. I know it's been brought up in the news quite a bit, a $15 minimum wage scenario. We're going to look at that right now.
All right. So thank you, Jacob, for that presentation. That was done very well. He spent a lot of time researching that, so we appreciate him for that. So now this is the standard PI Plus and all of the other different models that we have. This is the basic home screen. This is what you'll see across all of them. And we are working with a demo model that Jacob had already mentioned before. So this region isn't necessarily something that represents a real region, but it is still helpful to understand how the model works. So the results may not be, true to a specific place, but it still runs the same kind of equations and everything like that. So if you do want to look at what your profile, the regional profile of your specific model, you can do that from the home screen. And so this kind of just has a basic overview of what your region is made of. So how your employment's made up, through what industries, how much population you have, and we have a single age cohort in the new 2.3, which was mentioned in the last training webinar. And so you're able to see that in the makeup of your population, work profile, wages and salaries, and total employment. And so this is a little bit more detailed of the work profile, with a few more other things included in. And one thing that's very cool about this regional profile is that typically you're able to add the map on top of it of the United States, and so you can kind of see where your region is. Unfortunately, we don't have that in the demo model, but it is a capability and sometimes can be useful for analysis. So with that, we're going to move into the regional forecast, and I just want to show how I calculated some of the things, or just calculated the change in wages for the simulation. And so something not coming up. Okay, here we are. So here's the regional control, which Jacob had already spoken about, but I'm just going to go through how I calculated the 21.7% of increase in wages. So if I want to search any result, I can do that, which makes it very easy to find what I'm looking for. And so I'm going to look up annual compensation rate in terms of income. And so for this minimum wage scenario, we're going to do it in a very simplistic way. This is not going to be an exhaustive analysis as you would typically do if you're going to publish a study. We are doing this simply for demonstrative purposes, so we did not go into a full simulation. And so what we're going to do is apply the minimum wage to just a single industry. And typically what you would do is find the proportion of all minimum wage workers in the industries that you want to apply it to. However, what we did here was just take the average wage, and I want to change this to thousands, which I can do through units, and I can display my currency in thousands, and here you can also display your people in different units and also change the default currency. So with that, we're going to start our minimum wage change in 2020, and so we see that the average annual compensation rate is $25,516, which comes out to about an average of $12 an hour, $12.31. So instead of changing the minimum wage, we're actually going to increase the average wage to $15 an hour. So what we did was calculate that in terms of an annual salary of $30,600 and do a percent change equation to find a 21.7% increase. So with that, we are going to move into a new simulation. I've already have it run because with these webinars, sometimes the model doesn't run perfectly because it has to also cast the webinar at the same time. So we try to pre-run that so that we don't run into as many problems. So here is the list of all the inputs that we can do. You can hit the full list, which will give you, like it says, a full list of all the policy variables. But what we've done ahead of time is create some of these groupings, which we find, a lot of our clients might be interested in doing. So we have one made for the minimum wage, which is just a group of common policy variables in a minimum wage scenario. So we have things like compensation, labor productivity, production costs, consumer spending, and everything else that we see here. And so the reason why they're all in here, and we don't just have one minimum wage policy variable, is because everybody's running their policy, their analysis a little bit differently. So some people might include labor productivity in their inputs instead of having the labor productivity change through the model, because they have a certain idea of how the labor productivity is going to change in their minds and for their analysis. So, some people might assume that workers are going to be replaced by robots in terms of a minimum wage analysis, and we see that sometimes in grocery stores and other places. So, and then we have other times that you might want to run labor productivity in terms of when you're paying somebody more, you expect them to produce more, and so this is going to be things that you and your team would do beforehand, and REMI will be there every step of the way to kind of understand what you're trying to accomplish with your analysis, and also so that we can help you run a proper simulation. So with that, for this analysis, we're only going to do a compensation change, and so what we're going to do is hit select on this compensation, and so we have a new screen that comes up which has a couple different options. And a lot of these policy variables will have, sometimes 3 or 4 and even more options within each policy variable. So it's important to understand what this, information box is telling you about the different policy variables. So we have one with just regular compensation, which would just increase the amount of money that a person is making on the year. And so we're just kind of, with that compensation policy variable, you're just going to be adding money in the hands of the workers, and you're not going to make any changes to production costs or productivity or anything like that. Now, with the compensation rate, we are going to assume that it's going to change the cost of labor and production, which is what we're going to be doing today. We're going to be looking at a change in compensation with the cost of labor and production included. And so next you would choose what industries you want to apply it to. And sometimes it's easier to kind of look at it at a higher level to kind of find what you want to do. So here you can click on the hierarchy, or you can go back to the list. Either way, still very easy to navigate. And so I'm just going to apply it to the food and services industry because as we know, there's a lot of minimum wage workers in that industry. So then we can move into what region we want to apply it to. So, sometimes you'd only want to apply a policy variable to one region if you have a multiple region model. If you want to only do it in the city or only in rural counties or somewhere in between. For the sake of this demonstration, we're going to aggregate all of these regions to make it kind of one region. But next, we would do our unit type that we would like to enter into the model. So we have, for this policy variable, percent and proportion. Other policy variables might include things like nominal, a nominal change, or some other things that we might see. So today we're going to be doing a percent change, as that's how I've calculated it. You can do a proportion, which is essentially the same thing. It's just different entering it into the model. So once we add it to the editor, we can go ahead and look at the values to be edited. And so we have a time series here, and we're only going to go from 2020 to 2030. And then what you would do is hit the calculator button. And so we're going to do a 21.7% increase. And so since our units is already in percents, we don't need to turn it into a decimal. It will change it for you. And if you were going to do a proportion, you could do a 1.217. And so you can add that to your inputs list, and then you can see here, this is what you would do right before you run your forecast. And it's always a good idea to make sure that what you entered is what you want to be run in the model. So you just kind of do a quick glance over and see compensation rate, yep, to this industry with these regions at, percent, and then so on and so forth. So then after that, we find that this is what we want to do for our simulation. And so we can run it from 2020 to 2030 because it's not necessarily important to look at something that you didn't change. So then you can just hit run forecast. And like I said earlier, it's not necessary to run this since I've already run it prior to the webinar. And so here it is. And so what you'll see first is what we call this economic summary. And this is kind of the biggest hits of the simulation. And what I like about this is that it's kind of a good check to see what you like to see if what you did in the simulation is actually what you're looking for. Sometimes you might input something incorrectly and it won't make sense intuitively, so you can go back and kind of check your work. We know with a minimum wage scenario in economic theory that we can expect maybe a decrease in employment, and we see that here. Maybe an increase or a decrease in output depending on some other factors, and we can see that it could be true. And so we kind of just make these quick checks to make sure that's what we're looking for. This is also valuable to find the most important data from the simulation all in one place. So now if we go into the model linkages, which Jacob's already gone over, we can kind of see where or what we can expect from the simulation. And so since we made a compensation rate change, we might be able to see a difference in disposable income through the grapevine. We might be able to see a difference in employment, and we'll see a lot of factors through output. Compensation rate, that changes a lot of different things, including people's income. It changes production costs, which can affect the market shares, which will in turn affect output. Another thing that can happen is that compensation rate increase can change the employment, and employment has an effect on population. So people might be moving out if they don't have jobs, and from there, population has an effect on state and local government spending. So there's a lot of things that we can look at in the simulation to see what the results are. Now, again, this is all what story you're trying to tell for your analysis, and understanding the impacts. We have the results, and we can help find those results with you. But here's a great way to understand, how the model is working, and you can even kind of click on this usually, but I guess not in the demo model here. But this will take you right to the result of that output. And so another thing that we've added in 2.3 was this impact profile. And so here is a great way another way to see these huge changes. And you can even see like a ranking of your results. And so I think that this can be helpful here. I think that we're able to see the changes in employment by region here. And then this is what I find to be very interesting about this module, is that we're able to see that we made a compensation rate change to the food services industry. And so we're able to see that employment is falling significantly in that industry. But since people are getting paid more in that industry also, we can kind of see that spending is going to other places, and employment is increasing in other industries. So I think that is pretty valuable here. And so if we want to look at anything in particular, I think sometimes searching for the specific result variable can be very helpful. So if I want to look at, how do production costs change, or something else like employment, and we have employment by industry, and we also have employment by region. So you can kind of see the map of how things are going to change, and we've recently added how you want to see the differences in employment. And we can go into demographics and look at how people are going to be migrating in and out of the region. And we have this by ethnicity, by gender, and by age. And we recently added in the 2.3 the single age cohort. So you can see all ages from 1 to, I believe, 64 in males, and even sometimes you can go up to 100. And so we're also able to see it by race, and this is all based off of the BLS and the BEA, and also census data. So this can be very helpful for understanding things for your particular analysis, and you can even make it more detailed so that some of these things come out more accurately, which again, this is a very simple demonstration, so a lot of things aren't going to be as detailed as you might want it in a summary that you're going to be publishing. So yes, so we have some other things that we can go through here. Going back into snapshots, how's gross domestic product going to change? This can be important because a lot of policymakers and voters are interested in how policy is going to affect the GDP of a region, and we can see this by different categories, and so this is by GDP components, and we can select all regions. And one thing that's really cool about the new software is that we're able to change the filtering of the data, so we can exclude certain years or include more years. We can exclude regions from the filtering ability, so all this we would find up here. And you can also change the way that your data is displayed here. Through your pivot, you're able to, if you want to see all the comparison in the stack, you can kind of see that, and a lot of times this helps in the graph form. And so if you want to set this to table and do this that way, sometimes this can be very beneficial to add the comparison in here. So if you want to look at, you know, the differences, levels, and percent changes, and percent of nation and everything else all in one table, that is available for you. So all of this it works very well with Excel, so you can copy and paste this. You can also export this, which is helpful to either create your own graphs that look a certain way for you and for your analysis. And we're also able to look at different forecasts. So if you want to modify your forecast list and say you had two different policy scenarios that you wanted to run and check the differences between the two, you're able to add another one. We only have the regional control and this one forecast available, but this is how you would do that. And sometimes that can be helpful to understanding kind of the differences in the levels of different scenarios. So, you know, with that, I think I want to honor everybody's time here. And so we usually try to run the webinar for about 45 minutes, and we're coming up on that, and then we'll leave about 15-ish minutes to answer questions. And so with that, I think we will conclude this portion of the webinar, and we will move into the question portion. So there is a questions box for you to enter any of your questions, and we will answer those as they come in. And I want to thank you guys for your time and for your attention, and we'll be happy to answer those questions now.
Yeah. And with that, once again, we will have this as a recording out there for anyone that might want to see any of the specifics once again. Any questions that you might have, we'll be happy to answer. If you happen to think of them maybe later on, feel free to email us. We're always open to answering any questions you might have on the model. There's one question that's come up. Are employment numbers the number difference from the previous year? So I think what they're going with that is actually, Mike, if on yours, if you pull up that economic summary.
Yes.
Okay, so I'm assuming what they mean. This is actually kind of a question that we get sometimes. When we're looking at the total employment and we see this, so in 2020 we see negative 1155, in 2021 we see negative 1358. So when we see numbers like that, the question is that saying then that that's sort of a difference per year? And the way it is that is a difference compared to our baseline, which is if this policy change didn't happen. And so with these numbers, like if we see 2021 versus 2022, it could be that the same sort of 1,300 jobs that were lost in 2021, those are also then lost in 2022, and maybe there's 300 additional jobs that are not there as well. I guess an easier way to think of that is also if you have job gains from say a development project maybe, and you see 1,000 jobs every year maybe, those could still be maybe the same jobs. There's no way of knowing for sure with this, but I think then that answers the question in terms of how are those employment numbers calculated. All right, and we'll wait here for another few moments and see if anybody has
questions. Please go ahead and enter those in.
Yep. And also, if anyone has any specific projects or scenarios they're working on that you're kind of curious if something like this would be a good fit for working on that, then feel free to please ask that, or once again, feel free to email or call Mike and I. We have our information on the email from REMI. We'd be really happy to hear about what you're working on and see if maybe we could be a good fit for working on that. But I think then that'll be all. It doesn't look like we have any other questions coming up.
There's one.
Okay, so here we have, in the minimum wage increase example, some amount of out-migration was induced, presumably due to the reduction in labor demand. Are these migration responses assumed to be instantaneous, or is there some threshold trigger associated with labor market conditions that generates the outflow of labor? So we do have in the model a choice between sort of instantaneous labor market clearing, or if you want there to be sort of a frictional response. Let me actually share my screen and see if I can pull that up. Show my screen. I will admit I haven't actually pulled up this in a little while, so let me see if I find it in here. Let me do a new forecast. And let me full list. I know, for instance, let me pull up production costs, because one other way that people sometimes use this scenario is by looking at production costs. I believe that this has a lag market share response. So this is a little bit different, but in terms of the response, you can oftentimes with these policy variables, you can choose if it's going to be immediate, if it's going to be kind of a lag response. And there is not a specific sort of threshold that would generate the outflow. In terms of how it works, it tends to be, there's always sort of a proportion that will leave in response. But in general, it'd probably be a much smaller proportion if this was a very slight increase in that minimum wage. Yeah, and I think then that would be my answer to that question. If you want to go more in depth with that at some point, we'd be happy to discuss that in more depth over email or over the phone. All right, and so with that being said then, I think then we will turn off the broadcast of this. I want to thank everybody for tuning in with this. And once again, always feel free to reach out if you have any thoughts about our model or have any inquiries into how you might want to use it. All right, thanks everybody.
Thank you, everybody.